So it's always fun to do the first activity after lunch. So we'll see. Hopefully we'll keep your energy up. Hopefully you guys won't be sleeping on us. My name is Keith Lazard, and with me we have Bob Tordella. We're from J&J, and we're really excited about being here. This has been a journey for us for the last few years with great partnership between J&J and AWS to actually get to where we are. And it was fun. I mean, even this morning with Andy's keynote and so forth to talk about how we've transitioned over the last few years into the hybrid story that we're going to spend a little bit of time today talking about. So if you look at kind of some things and so forth we want to cover in the session today, really just give a view of how enterprises have these different challenges and so forth that we're facing every day. What are the different ways that we're leveraging the cloud in order to actually enable some of these and push us forward? And with that, we're going to go into details and talk a little about our approach. We're very, very happy, as well as we're very proud of what we've done over the last few years to enable self-service cloud management. And so we're going to give you a view of how we do things. What is our approach? What is our strategy? Give you a view of our architecture and different patterns that we made available throughout this journey we've been on. And then end with some lessons learned. You know, this is not something that you could tell that between day 1 and day 1,000, you know exactly each step along the way. So how we've been able to change and adapt, always having that same strategic intent of what we want to accomplish along the way. So with that, hopefully you guys know who J&J is. Most people, you know, think of J&J, they think of Band-Aids, they think of baby shampoo, they think of the products and so forth that you grew up with, or for those of you have kids that you use on your children. What's interesting, though, is around the complexity and the number of different companies associated with J&J. So 270 companies across the world. And with that, that drives a level of complexity for us from an IT perspective. So these are the core challenges that we face every day. So we have thousands and thousands of workloads and systems. So 15,000 applications running across the globe. Some of them were based off of homegrown applications, but a lot of them come from mergers and acquisitions along the way. So with that, that really complicates our overall IT support model. Having a consistent way for us to be able to drive the value for our customers is what's critical for us. And with that, when we have this fixed asset with respect to our legacy and so forth, it makes it really difficult for us to be able to change our financial targets every year. We have such this fixed asset from an operations and from an infrastructure perspective. So if there's a year where one of those 270 companies was having a challenge, it's really difficult for us to spin down portions of the environment in order to give financial benefit back. So the cloud changes things. It gives us a great opportunity to actually make a difference and actually change what we want to do moving forward. So one is automating everything. You know, if you think of everything that we all do every day in this room and so forth, is how do we drive code to manage infrastructure effectively? And with that, have complete transparency and ownership of those costs. So as you want to be able to spin up more infrastructure, you're going to pay for exactly what you use and leverage those principles to then develop common patterns and solutions to reduce the time to value. That's the benefit from an agility perspective we're seeing within J&J, is how can I be able to get to our business solutions and access to the data more effectively, more efficient, and in a more cost-effective way. So this strategy is based off of this hybrid. And so, you know, Andy talked a little bit about that this morning during the keynote. And Dan Zalem, our CTO, actually talked about this at the keynote last year, where we're going down this path of an on-premise private cloud and a public cloud built and powered by Amazon. So our on-premise cloud is based off VMware, being able to really drive the self-service nature there. Our public cloud is based off of a multi-region deployment with respect to AWS. What's interesting about that, though, is the common principles across our on-premise and private and public cloud are going to be the same. So everything from compliance, data protection, operations, and transparency is what's key and so forth. So today, I'm going to spend all the time talking about VPCX. And so VPCX is our team. It's our term and so forth that you're going to see throughout the hour today, and how we're trying to enable this vision. And this vision is to empower our business to provide a scalable, secure cloud IT platform all based off self-service. So our goal is to enable agility, leverage the core principles of the cloud itself, but at the same time ensure that we have the policy and controls from a J&J perspective are always adhered to. Having that automation to be able to enable that on a day-to-day, minute-to-minute basis is kind of what is the fabric that we put on top of the cloud to actually make this work for us. But having this and having a common solution, it also enables us to see those common patterns that we're seeing across J&J. So how can I have these best practices enabled and then make it easier for people to get to value? So with that, it's a little easier said than done. So you think of all the controls and the configuration options, we look at it through two different ways. We have preventative controls as well as detective controls. So from a preventative perspective, we build the fabric that we call XBot, that we're going to spend some time talking about the architecture and the approach to that, where we have preset configurations and management of the cloud itself. Everything from J&J network integration, AD integration, our white policy of IAM and so forth, all that is managed through us from a preventative perspective. But there's some things and so forth we can only do from a detective perspective. And those are the things that we leverage our code and our automation on top of the cloud to actually make happen. All these are based off of a core principles that pretty much every enterprise would want to enable. So one, we enforce the least privilege approach. So as we talk about enabling cloud accounts and particular applications living in the cloud, we started with the bare necessity, the smallest amount of capability to start with, and we only onboard these capabilities and these configurations when people need it. So as we go through examples today, we'll talk about our approach for how we enable this from happening to happen and be able to actually manage the environment in a more cost-effective way. Logging, we're going to spend a little time talking about. The two I want to focus, though, is give a view of our account isolation. So for us, we have a very unique policy in how we're doing this. Each application is its own AWS account, and with complete isolation from each other. This provides us a lot of different capabilities with respect to cost transparency, as well as providing the most secure environment that's isolated from each other. So as we spin up one account, one environment itself, all the security groups, all the principles from an IAM, all the access controls and so forth are specific to that one application. So I can actually have a very small blast radius at the individual AWS account perspective. So what we built, and Andy actually kind of beat me to the punch today, is around the XBot environment. So what we have in place is what you see on the left side of the screen, which is XBot. And these are all of our central policy enforcement engine that we have within J&J itself. Each application actually gets connected to every 10 to 15 minutes to describe the environment itself, understand what objects are in those accounts, and see if there's any drift away from our core policy, core enforcements that we need to actually adhere to from a J&J perspective. This allows us to actually have that isolation I talked about, and we're going to spend a lot of time talking about through the rest of the presentation today. And with that, as there are things that need to be done, whether it's managing drift, changing policy and configurations, we do that automatically in those AWS accounts, as well as there's things that the application teams need to do. We actually automatically create tickets and assign it to them to actually manage the drift themselves. So that's at a high level. Let's go into a little bit more detail. So this enterprise control is set up through this high-level architecture. And I'm going to start talking about the bottom, and that's the metadata. So we have a Dynamo database where we store all the project-level details, all the information on a per-account basis of what is allowable in those particular accounts, what is the particular chargeback and reference IDs and codes and owners and so forth. All that is stored in that metadata repository. On top of that, we're leveraging Python and Bodo for us to be able to execute and describe across those hundreds of individual AWS accounts themselves. Through that, we inspect every single object through doing describe functions of those particular cloud configurations from an EC2, RDS, S3, and so forth, for us to identify the drift. If there is drift, what we do, then we actually create a queue item that goes into our work queue based off the priority to then execute those configuration changes back into that environment itself. And then if we need to, create these tickets to be able to assign to either ourselves from a core cloud team or back to the individual application owners and teams themselves for them to take actions across the environment. So if you look at some of the example controls we have in place, here's a very simple one that many people probably resonate with is we control the AMIs, well, what's stored in the cloud itself, right? So we leverage only J&J approved images for RHEL as well as Windows. And so for us, we need to go across all these individual cloud accounts, identify what VMs are being stood up in the last 10 to 15 minutes, and then identify if that's an approved image for that particular account. As much as I would love to say the fact that, when you have a company like J&J, you have the consistency across it, there's always exceptions. So for us, one of the things that we built is a way that on a per account basis, we could have allowable AMIs associated with those particular workloads and so forth. And all that information is stored within our metadata. So I mentioned before about DynamoDB as a repository of our project level information. You can see here that we have this information available for us to be able to execute both our CLI, our automation, as well as just from a reporting perspective. So here's an example of just our project metadata that we store on a per account basis. And then I mentioned before about exceptions. So storing at the individual project level itself, what are those AMIs and those exceptions across those EC2 images? This has been our transition over the last few months where we're continuing to store more and more information in Dynamo so we actually have a repository of what happened at that cloud environment at what point of time so we can actually do better reporting, better visibility, and be able to have greater insight with respect to points of time of what J&J's version of the cloud was. All this allows us to do some pretty cool things. So I mentioned before about automation is key and the fact that with this change from a hybrid perspective, we needed to be able to reduce the operational cost and time to be able to manage the environment. We're doing this based off of our CLI and our automation itself. So for here's a basic example of looking at me as a person to see what dev accounts I have access to. I'm able to actually very quickly be able to identify and make changes to all the configurations and the information that's stored on a per account basis. So here I'm able to look myself up, and then I'm able to look at all the different dev projects we have with our account code and what's the friendly name associated with that environment itself. And then I'm able to actually make actions on it. So in this case here's a blank dev account that I'm able to look at my project metadata. What is the cost center associated with this AWS account of what I need to do? Who's the financial owner? Who's the different things that we need to do in order to manage this from an enterprise perspective? But on the bottom is the interesting part, where I'm able to actually see, here's the project level service listing. So by default, this account only had EC2 as an allowable service on it. Through our CLI, though, we're able to actually automate adding additional services into the fold. So in this case here, I'm just taking on that same account, I'm updating that 045 dev account, and I'm adding RDS as an allowable service on that account. Behind the scenes, this will run through our automation from a CloudFormation IAM templates to add that service in. This is a way that we're able to actually reduce the time, but still enable that least privilege option that we talked about in the beginning from a principal perspective. So for us, it's an interesting balance of enabling agility, but at the same time following through with that least privilege approach, where I'm only adding on services after they are approved on a per account basis, all through code and all through automation. So if you do the next describe, you can kind of see the fact that now this account not only has EC2, but RDS is added into it. So at a high level, from an account perspective, our goal is to enable the flexibility and agility of the cloud and be able to add on services they need to. Bob's actually going to go into now and talk a little bit more about at the operating system, database, as well as infrastructure control perspective.
Yeah, thanks, Keith. Hello, everyone. So at this point of the presentation, we're going to go through how XBot could be used as a centralized service and then be able to control hundreds and scalable to thousands of Amazon accounts. Today, we're at scale for over 500 Amazon accounts that we're running these type of policies within. So we'll talk about how we manage our network constructs as well as our infrastructure layer, which is really your Amazon APIs or Amazon console layer. So all your instance, your objects, your buckets, et cetera. And then we'll talk about how we control on the compute layer, the operating system layer, and then on the database layer, we'll go through an example of what a user experience looks like. So as a user spins up a cluster, how do these policies then get enforced in the environment? And then afterwards, this is really just for any use case. But then we have more complex use cases that require different architectural patterns. So I'll showcase what maybe a HPC or high-performance computing environment looks like, and then how we've architected our Workspaces architecture that's rolled out globally. So from an XBot environment, it is our central control framework. It is our central account that is considered our master account. From there, it has trusted relationships to all of our child accounts or all of our application accounts. And how we control that is that we first, as a central team, our VPCX team, we're handling the account creation. And so yes, right now it's very manual, there's no APIs, but we've automated HTML scripts to try to help that along. But when we create these accounts, we take over as root first. And then we abstract root, and then we start layering policies and controls in place based on our templates. And that's where CloudFormation really comes into place. And I'll go through what each of those CloudFormation templates that we run in the environment and how it then starts building the policies and buildings of the account. Now, another enterprise control we have is enterprise billing. We've often heard from peers that there's challenges with how you handle enterprise controls with billing and how you do chargebacks. But simply for us, because we're in a multi-account model, every application is isolated, as Keith was mentioning before. So everyone is doing their own workload within their own account structure, so they're paying for what they use. And through consolidated billing, which Amazon has as a feature, you can have a payer account that consolidates all your billing. You can have one master purchase order with Amazon as a central entity. And then through an internal chargeback process, we're able to charge back each and every single account for their own individual utilization and workloads. So let's take a look at how XBot is starting to layer policies. So from a CloudFormation template standpoint, when we first create that account and we take over as root, we have that root API where then we start layering in other type of credentials that are federated into the environment. So once we abstract root, we actually multi-factor root out. We have it so two people have to authenticate in order to actually ever get to root. And so really the major hook for us is a master administrator role that has star policies in the environment. So that gives us that type of trusted relationship to programmatically manage each and every single account, regardless of the amount of accounts that you have. And so the first stack is really defining that. It's building the administrator role. It's building read-only roles so our support team can actually support end users when there's issues in the environment. They can just go in and monitor metadata. And then we start building out other type of users and roles that are for our third-party integrators. So whether we're doing metric or users reporting or log management, which we'll talk about later, those are all trusted roles in our environment with very limited IAM permissions, but that's part of the core stack. Those are very high-level core needs that we need in order to manage any type of Amazon account. But then there's different types of Amazon accounts that we provision. And so the first basic one is a lab account. And so a lab account has no connectivity back to Johnson & Johnson's network. There's no direct connect, no virtual gateway. It's solely used for workloads that just want to trial new things out. Maybe they're using untrusted AMIs or they're trying to just more of a playground. Right, so that's a certain project template that we have that we'll push through as a project CloudFormation stack. Then as another type that we have in the environment is what we call our VPC account type. That actually starts provisioning all your network constructs for your virtual private cloud, your routing tables, all the standard security groups that we define by default that allow for connectivity back to on-premise, which as well as with the virtual gateway and a few other components that we automatically automate through CloudFormation. And then the other type of account is to not actually use a VPC at all, or not a lab environment. It's just to simply have teams that just want to use S3 only. Right? We don't necessarily need to provision a virtual private cloud and waste networking space on premise. We can actually just give them an account without a VPC construct so they can use public endpoint services like S3, Dynamo, Kinesis, et cetera. Within the project stack, that is also where we put our whitelisting policies. So one of the preventative controls that Keith talked about earlier is how do we prevent people from doing certain actions that aren't allowed? And those type of whitelisting policies will not even allow the possibility of an IAM permission to be applied. So if we're not approving Route 53 in the environment, we simply won't have it as part of the standard whitelisting for that account type, right? Or any service that might not be already whitelisted for a certain purpose. But as Keith mentioned earlier, XBot's able to push different services within the account. And so although the core and the project stack are used for any type of application workload, we then start layering other type of capabilities or services depending on the workload. And so for least privilege rights, if a workload only needs EC2 and RDS, we will only enable those type of IAM permissions to be allowed to be applied to an end user. So what we do is, if we enable EC2 or RDS, we have predefined IAM groups that will accelerate the teams to automatically apply to users in the account. Those IAM groups, we accelerated to have maybe an administrator role that can do a lot of things within EC2. They could start, stop, terminate, et cetera. And then an operator role or power user role that has limited permissions, but it has some type of functionality that maybe people can start and stop, but they can't terminate. And then a read-only role or monitor role that just allows people to actually monitor the environment. And so people can pick and choose these groups, so not everyone has administrator rights for EC2, for RDS, et cetera. You can segment them depending on segregation of duties. Now, our user stack is where we're syncing Active Directory security groups per that applicable account. We then sync those users. So what users are in a security group, we then map those to IAM users within the account. So in this example, myself as B. Tordell and a few members of the team are associated to this Active Directory security group for this specific Amazon account. Through XBot, we run sync jobs that automatically sync the users. They identify that if they're in the Active Directory security group, they'll then push those users through a CloudFormation template, then we'll add them as an IAM user. And then similarly, if they're removed from Active Directory, maybe they left the company or they moved on to another project, similarly, we'll then remove them and remove them from the project or the user stack, and then they'll get removed from IAM. Another major CloudFormation stack that we put in the environment is, and another control that we have, is when people spin up compute or they spin up databases or clusters in the environment, we automatically apply best practice CloudWatch alarms. And so these are based on certain thresholds that we define as by default. Like, for example, if CPU utilization was hitting 95% for 60 minutes, we'll automatically have an alarm on that instance that will then notify them through our ticket system that Keith talked about earlier. So as instances are spinning up, we are then pushing the CloudWatch alarms through our alarm stack, which then is applying them to the instances. So this one can get very expansive, and we have nested CloudFormation policies that then nest the two and then map them. Now, that was for all the core workloads, but then we could start iterating beyond that. So these CloudFormation stacks that we just talked about can be for any type of workload. They can handle 2-tier, 3-tier architectures, or very simple POC workloads or production workloads. All the constructs that we set up through our templates can handle that. But then when you start getting into more advanced architectural workloads, which I'll talk about in some architecture slides later on, is then how can we enhance that capability? How can we start adding new capabilities and templates and services? So this is an example of our high-performance computing stack that then starts adding other type of virtual private cloud configurations, security groups, whitelisting different services. So I'll showcase what that architecture looks like on a later slide. So that was the infrastructure layer, right? But XBot extends itself to also be on the compute layer or the operating system layer, as well as the database layer. So Keith referenced one of our major operating system controls that we have, and that's to enforce our Johnson & Johnson images. We want people to use our J&J images that we've pre-configured. We have through our software configuration management policy. So when these instances boot, they fetch the latest repo, and then they bootstrap themselves, and they come up as a standard Johnson & Johnson image for Windows and for Linux. And that's the biggest control that we have from an operating system perspective. But we go a bit further. Once we detect an instance is created, we do automatically start patching, backups. It's integrated with the CloudWatch alarms that we talked about earlier. So there's a lot of controls centered around the compute layer as well as the operating system layer. Now, for databases, what we're going to talk about a little bit more is because we spent a lot of innovation time and a lot of cycle time on iterating on top of the great services that Amazon offers today. So RDS and Redshift are awesome services. If you guys aren't using them as your first in-class databases, we recommend that you do, right? Because these services eradicate the need for platform database administration, right? You can use these to accelerate your application database design, schema, tuning. You don't have to worry about the platform layer. But at Johnson & Johnson, we have a lot of internal controls. We have a lot of security measures that we must enforce, such as centralized logging, logging all user activity on the database logs, correlating them, ensuring encryption depending on the type of workload. So there's a lot of different practices that we needed to automate to allow us self-service control in this environment. And so the next few slides, I'm going to talk about how we manage, and we'll just use Redshift as an example, how we manage Redshift controls when a user spins up a cluster. But what we put together, although I'll just be demonstrating Redshift, the innovation that we put into this is that they're the same logical controls regardless of your database engine. And so I think we all understand the complexities that every single database engine is different. They manage different schema designs, they define tables or databases differently, different ways that they do store procedures, et cetera. And so the challenge for us was how to make a consistent model for account management, for logging, for profiles, et cetera. And I'll showcase what that looks like from a Redshift perspective. So going back to an example where Keith's slide, where he was talking about how XBot works. So very similar for when we're doing controls on a compute layer, it's the same type of process that we do on the database layer as well. And so for XBot, it's centrally managed, Bodo. It's taking data from Dynamo, our account metadata. It's then feeding that information into variables to run the jobs that we run every 10 minutes. So all of our enforcement tests are running every minute. Most of them are scheduled on 10 minutes or other intervals. And that's what's enforcing policy in the environment. It's detecting if new databases or new compute layers or new S3 buckets are created, and then we automatically enforce policy. And so whether it's a new bucket or it's a current bucket, these jobs are running constantly in the environment. And so for databases, it's the same method. We're using SNS, we're queuing the jobs up, we're integrating with our ticket system as well. But for databases, we also lean into KMS to manage some of our credentials. And so one of the primary policies that we have with this environment to manage controls within the database is to actually take over as master user. And I'll showcase what that looks like in the next few slides. So this is just a sample, just all of our policies that we enforce within this. And it's missing a few, and I'm going to highlight a few of these that are here within the next few slides. So we rotate the master password when we take over a database, but we constantly do that to ensure good control. We also enforce encryption where needed. We automatically apply the maximum retention rate on backups. We apply certain tagging based on some of our policies. And then we do a lot of sync jobs to add the users or drop users depending on how Active Directory Security Group is. So let's start from a user experience standpoint. So this is a CloudShare log. You can see me, B. Tordell, that's my NTID. I'm federating into an Amazon environment. So J&J uses federation, so secure token service, to actually federate people into the environment within time-based access. So this is an example where I'm creating a session, and then I'm logging into the console. Then very quickly, within a minute, I was able to create a cluster. So now Amazon is spinning up that cluster. So going to a Redshift event log, I can actually see here that my test DB3 cluster that I created was provisioned in just a few minutes, which is awesome. And now it's ready for use. Now what's happening in the background is that XBot has detected that now it's in a ready state. And so now the first action that it does immediately within those 10 minutes is take over as master user. It alters that permission, it changes the password, and then every hour it comes back in and rotates it again. That ensures that we have good control in the environment and that we're not abusing this type of right where we as a central team programmatically have hooks in every single database. But this is necessary for us in order to automate some of the controls we're going to talk about in the next few screens. So this is an example where we have an Active Directory security group. We got a few members of the team in there, so myself, there's Keith, and a few other team members. And when those users are in that Active Directory security group, we run that sync job to then add them into the database or the cluster. So here you'll see that the create time was relatively within the same, that these users were synced in. And then the next policy is where we actually start creating the profiles. So because it's a new cluster, it doesn't have our profiles that we want, the right grant permissions that we expect for these database administrators. So we create the group, we then create the policies against that group, and then we add the membership to that group. So basically we're creating profiles and adding members to it. But we go beyond just account management on the cluster itself or within the database layer. We also try to automate best practices. So from a Redshift perspective, it's best practice to abstract the need to use the public schema. So we revoke access from anyone within the database to actually use the public schema and just use their individual databases or schemas that they create. Now, while this is happening in parallel, we're also running other XBot tasks that are occurring, and they're starting to apply other type of automations. So this is an example where, from the CloudTrail logs, you can see that we updated the stack. We detected the cluster. We updated the stack with the alarms, and then we put the alarms on the actual cluster itself. And so here's the example of the alarm stack with the actual configurations that we applied from a CloudWatch perspective. So some of the core, we do a lot more than these, but some of the core that are screenshot are CPU utilization and memory utilization and health checks. Those are very common regardless of the application workload. Those are just best practices to be aware of those type of thresholds being breached from an SLA perspective. Now, also within this enforcement period, we're also taking a look to say, hey, is logging turned on? When they provisioned this cluster, did they turn on logging to send to S3? Right, so that's a benefit within Redshift that it's an API action to actually take your logs and move them to S3. But then also, did they enable the maximum retention period for backups? Right, did they select 0 or 1? Whatever it is, we enforce the maximum retention period per internal policies. And then the tricky part is then managing parameter groups. And so, as you guys know, for RDS and Redshift, Amazon does an awesome feature where they pull out configurations and options, and they put them into an API action group object setting. So therefore, you can create these parameter groups with some very specific profiles or configurations and apply them to many instances. And so here's an example where within the parameter group, there's two major settings in Redshift that we care about. We care about requiring SSL and setting that to true. And then we also care about setting user activity logging on. So by default, it's not capturing SQL statements from any activity within the database itself. And to have appropriate audit management of your environment, you need to capture that type of user activity so you can understand what's going on, if there's any misuse in the environment. And so here's an example where we identified the cluster. It created the parameter group because you can't edit the default. And then from there, it started editing the permissions within the parameter group and then applying it to the testDB3 instance. And so here's an example of the parameter group in Redshift, and really it's just a Boolean switch between false to true. So false is the default, and we just flag that then to true. Now, all these activities that we're running in the environment, if they're affecting a configuration of a cluster or an instance, we're ensuring that our users or the people within those Amazon accounts that we're programmatically managing are aware of what we've automated or what we programmatically controlled. And so through our ticket management system, we automate a ticket letting them know that we actually did some type of configuration. We give them good details to what we did and why we did it, and we have a lot of reference documentation that we built in order for them to reference. Now, beyond all those automated controls, we have other type of principles in our environment that we need to ensure from a good practices standpoint. And so enterprise log management is a big challenge of how we manage all these log information that's coming from all different types of services to all the API actions that are occurring, as well as all the operating system layer logging and database activity logging. How do you manage all that information at scale and then be able to do correlations around it? And so we put together a centralized log management strategy where within any Amazon account, we're capturing every single type of user activity across the entire stack. And so a lot of services make it easy for us to do this. So CloudTrail, Cloud Config, they all push all the logs to S3 within an account. And from there, other services like S3 access logs, data pipeline debugging, EMR debugging logs. Redshift has the features where you can push it to S3. It just seems like a logical place to aggregate, right? S3 is really inexpensive. It's scalable. You can dump your logs in there at very inexpensive cost. Now, when we started doing this, we started putting in every single account has a regional logging bucket that they own. They have full transparency to their logs, but we lock anyone from being able to delete a log or alter a log, and we handle that through S3 bucket policies. We also set then retention periods, so we're rotating the logs and we're not keeping logs forever. So we have certain cycle times that we cycle out the logs itself. But when you have this type of architecture where all of your logs are feeding into buckets, you can then plug and play whatever your favorite log management tool is. So if you wanted to plug in alert logic and play around and correlate with your logs, you can. Or you can plug in any of your other favorite log management tools for any different types of needs. Right? It's a very much scalable architecture where you can plug and play different SaaS tools. But one of the challenges we had was, again, in RDS or within Redshift, within RDS, is that with any of the database engines within RDS, there was no good feature to send database user activity logs to S3. Right? So because there's no easy API feature for us, we needed to take to XBot and automate controls in the environment. Since we have master user rights in each account or each instance, we're able to actually query out the logs from the audit table, store them temporarily, and then move them to S3. So it's our own integration process that we developed that automates this every hour. And then we also rotate the logs to make sure that the audit tables aren't filling up. So we also actually accelerate a best practice as well through this process. Right? So with all this, we actually have all the logs in one location. So this is an example of the S3 bucket for US that's maintaining all of these logs. And so whether it's the Amazon CloudTrail account logs, config, Redshift, data pipeline, EMR, they're all consolidating into one location. Right? And so we create our own folders that kind of mimic the same principles here that Amazon automates. So we have our RDS logs, and here's an example of where we're just collecting them consistently. But you can also then start applying your application logs in the same location. So you could start moving your application logs into this model as well, so that whatever log management tool that you're then integrating with can actually have all of your infrastructure logs, your operating system logs, your database logs, as well as your application logs, one location. So it's easy for you to correlate across. So there are a ton of services out there for Amazon. And our challenge as a central team, trying to manage these guardrails within the environment, is we have to keep up with all the changes. And we have to keep up with all the services that are in demand from our application teams across J&J. And just like the keynote today, they just announced 10 more, right? It's like, it's the pace of innovation is incredible, and it's what keeps us going, but it's what we then have to do to start enabling that for our business. How do we accelerate the tools like that were announced today to have the right whitelisting controls in place, have the right policies and enforcements? And that's our challenge, to keep staying on top of what Amazon is offering to ensure that we can get these services out to our team. And so although we talked about computing today and we talked about some database technologies, all these type of services that we use in the environment all have their own same level of controls. So we've automated these type of controls in order to ensure our policies and our security configurations are intact. Like for example, for S3, when people load up buckets and within S3, we automatically enforce bucket policies that have encryption at rest, encryption at transit, restricted to certain IP ranges, ensure access logging's in place. And so we have automations across all these type of services. But all that is really just for the common workloads, right? So that could satisfy anything. It doesn't matter what type of workload people move in. All those controls in place can satisfy anything. It can satisfy a dev environment, it can satisfy a prod environment, any type of business process that's satisfying from different regions or different business processes across Johnson & Johnson. But there becomes definitely a maturity when you start looking at different types of workloads. Workloads that might need to burst to thousands of compute nodes, or workloads that need a high intensity elasticity environment. Our standard patterns of how we deploy virtual private clouds might not be enough IP space for people, or might not be enough services enabled. And so we need to start looking at the environment on how can we enable bigger patterns. And so as a central team, we started realizing that a lot of our workloads were business intelligence related, or advanced analytics related, or big data related. And so because of that, we started looking at, okay, what are some better opportunities that we can start creating templates for these type of workloads? And so I'm going to showcase what a high-level architecture design is for a common high-performance computing use case. And so you start with an Amazon account. We then layer through our project stack. This is a connected VPC. So it has a subnet of our network. So in this example, it's a /25. Within this VPC constructs, we have nested subnets that go across 2 different data centers. That allows this simple design, allows for any type of pattern to then be set up for high availability or the possibility of high available workloads, that now you have a VPC across 2 different data centers that people can provision across. So with this, you have a virtual gateway that then connects through a direct connect out back to our data center. So this is, for all intents and purposes, an extension of Johnson & Johnson's network. Right? We have the routing within place. We have the direct connect that allows for the connection in between. So then teams from their laptops within our offices can connect to their instances within the cloud. People can connect back to internal data sources. Core services can be accessed like Active Directory and DNS, et cetera. And so with the Amazon services, you could spin up EC2 within a VPC, RDS, Redshift, et cetera. That can be within your VPC constructs. And then services like Dynamo and S3, Kinesis, and others kind of sit within your Amazon logical isolation, your Amazon account. But this is great for any type of workload. But how do you then handle a bursting of thousands of nodes? Right? So this in a /25, you're not going to be able to get to multiple hundreds of nodes if you need to scale out. And so for cases where we're doing high-performance computing, there's a notion of being able to create a private VPC in the same account. This allows for you to burst EMR clusters or EC2 compute nodes or whatever other services in order to burst out into multiple different subnets or into a private area. So classically, when we're using EMR or we're using EC2, we want to take advantage of spot instance pricing. When I'm limiting my subnets in a standard pattern to 2, I'm not taking advantage of the best possible bidding or auction pricing across multiple subnets. So the private VPC can be more expansive to multiple subnets. It can be more expansive to the CIDR block as well. Now, data comes at all different angles, but I'm just going to come through or walk through a very simple use case, and really what is most common. S3 is used as a simple aggregation point. Very similar to how we treat logs, many of our different application workloads treat S3 as an aggregation point for big data. And so whether we're ingesting small or large workloads into our VPC environment, S3 will be the common starting point for that extract layer. Right? So workloads will move to S3. And then S3 has a natural integration with EMR or with EC2. So from a connectivity standpoint, the data can move between the two. So as you extract into S3, you could then transform an EMR or an EC2, and that spits back into S3, and then you can integrate that with different services like Dynamo, Redshift, RDS. But that didn't give the full picture because sometimes you actually need to SSH or terminal into your instances, or you want to be able to move data on different type of non-web services connectivity. And so VPC peering can actually connect this whole model together. Right? You can actually move the workloads back and forth or the data sets back and forth, and this is within one account structure. The blast radius is only to one isolated account where it's not affecting our Johnson & Johnson network. And so we can do different types of workloads in this private VPC while still being connected to the other primary VPC. And then once you have your data orchestrated from an ETL or ELT standpoint, you could then start visualizing it with Tableau or your other type of services. But what's really interesting is the announcements earlier today. Right? So this is very complex architecture where you're having a lot of data movement across various different services. And then if you want to do like business intelligence, you want to stand up Redshift clusters, you then got to stand up a visualization tool architecture. But with the announcements today with Quick Insights or Quick Sites, that's going to allow us to eliminate that compute layer. Right? We don't necessarily need a visualization tool for basic use cases. And then for Spice, that's the in-memory component. In simple use cases, you might not actually need a Redshift cluster. Right? So some of those platforms as a service that they announced today actually simplifies this greatly. And even for some of your transformations within EMR, you can lean into services like Data Pipeline to actually then run transient transformations at a lower impact. So another huge architectural pattern that we enabled as a standard configuration was for our Workspaces rollout. And so last reInvent, Dan Zellum, our CTO, announced how we were progressing forward with Workspaces and leveraging virtual desktops in Amazon. And so in order to enable this, we couldn't use our standard architectural patterns, right? We needed to develop a broader way of how we're going to handle these type of controls. Because instead of dealing with servers and dealing with all the standard automations we think about for application workloads, these are virtual desktops, and it's a little bit different of how we would manage it. Right? We don't necessarily want everything to come back through our virtual gateway. There's other type of core services that we want to put into the cloud to have a lot of fast reads across different core services. So what we've done is we set up Workspaces VPCs within one account regionally that are very massive CIDR blocks to allow for tens of thousands of workspaces to be provisioned within them. They do have connectivity back through our virtual gateway, back to our data center to access internal sources. As for all intents and purposes, they're just a desktop in our environment. But there are cases where instead of having to hit Active Directory and DNS, we don't necessarily need to feed that back through the virtual gateway. So again, through VPC peering, you could start actually putting other type of core services in the environment where you can peer multi-factor authentication, compute layers or application workloads, as well as Active Directory and DNS. They can be peered in multiple different Amazon accounts, so you can have those workflows flow through the Amazon management plane. So on the next slides, Keith is going to close it up with key takeaways and lessons learned.
Thanks, Bob.
Yeah.
No, you can applaud for me. So one of the things that I'm most proud of, not as much beyond just what you're hearing here, is our team. And so with Bob and Cody and Robert and Alan and Mike, we have a bunch of people here. Raise your hand if you're part of the team. Hurley too. I forgot Hurley. This works based off of people who have a passion and a desire and want to continue to change. So what's cool about everything we just showed you here today, a lot of this can be improved based off of the announcements that happened today. So it's a never-ending cycle of how we could provide the innovation and drive better agility and efficiency in the cloud. And we've been able to do that through DevOps and so forth. And it's something that we've seen a lot of momentum here, but this is how it works for us. So every week we release new code, new capabilities to be able to make this happen and so forth. And that's what's worked for us, to drive our velocity up and be able to enable this. We've been only be able to do that though with the right leadership at the senior level to make this happen and allow us to do. So from our CTO as well as our security people. So our security organization is a huge partner of us on how do we build out these controls to manage it effectively. And it really builds an approach for leveraging the automation to make this work and make this successful and so forth. So that's been a critical partnership for us as we progressed over the years. The last is more of a fluffy thing. You have your principles. And so as you develop the approach and your strategic intent of what you want to enable from a cloud perspective, my recommendation is be diligent at it. There's always going to be ways or things and so forth that come up that's going to make you even want to take an easy way out or try something different. It's hard to stay diligent on that strategic intent. But that is something that you need to have a core group of people that are going to be that kind of lighthouse to go towards to continue to focus on what really matters, because there's a lot of other noise that will come up when you try and hit the scale that we've been able to achieve over the last couple of years. We focused on leveraging and leaning into AWS. And so, part of the initial work that was done, we did look at CMPs and so forth with respect to cloud management platforms. Where we think differently is around the cloud is more than just VMs. So a lot of the CMPs that we looked at and we investigated from a technical perspective really try to manage the cloud based off of managing VMs itself. We believe the cloud is more important than that. And so the PaaS capabilities that are coming out and the innovation that is happening on a per-day basis is what we want to tap into and leverage for the betterment of J&J. And so that's a core principle, and we haven't seen a CMP yet that's been able to adopt that same type of principle we're looking to do. From a partnership perspective, Bob talked a little bit from a log management. There's a lot of solutions that we've had to build a bridge together for this, from a management, from a log, from a control, from a cost perspective. Building out those partnerships, understanding where it is, and then having an open dialogue with AWS on where they're going to understand some of those new capabilities that they're trying to do in order to continue to complete the whole cycle within this overall management environment. And then last is training. This is a big shift with respect to enabling self-service cloud for our application teams. This is not something that happens overnight. This is not something that is easy for a lot of people. We're moving from a central IT function where we would provision on behalf of all these application teams to now enabling complete self-service for them within the guardrails for us to make them successful. So we've had to actually really spend a lot of time to provide the training and continued education on the core foundation we talked about here. But then as new announcements comes, how do we continue to educate people on what is the next set of innovation and so forth? So there's a lot of time and effort spent on this, and I want to make sure people realize to plan for that and be prepared as you want to hit kind of the size and scale and so forth that I think we all want to achieve. So over the last 50 minutes, we spent, if I can hit go, hello. So AWS, you need to create a new clicker for this to work. That's next year's reInvent.
Here.
You got it? Thank you. So key takeaways. I just kind of did my rant on PaaS, but I'll say it again. Leverage PaaS. It's good. It works. It actually makes your job easier to drive innovation for your end customers and your end value you're trying to do from a business perspective. The agility of the cloud is critical. Don't be a bottleneck. Leverage self-service. There's ways you could build controls through automation in order to manage the scope and the configurations that traditionally you do things in the past through manual and other processes. Lean into it. Lean into the self-service model. Through automation, you can make this work. You can actually do exactly what we say here. And as we saw from some of the announcements today, it can actually be easier than all the work that we've done over the last few years. Last is there's a lot of different patterns that are available. Don't be scared about going big. Think of the high-performance computing and big data pattern that Bob just talked through a few minutes ago. They're there. They're available. There's a lot of best practices. There's a lot of information in order to make this work. Hopefully today you got a little bit of a view with respect to some different options or ways to think about these controls in order to make it work for you from an enterprise perspective. So thank you all for the time today. I think we have about 7 minutes for some questions, but from an overall perspective, don't forget your evaluations. Here's our contact details. Feel free to reach out to either myself or Bob. Would love to connect with you while we're here. We're here through Friday and so forth. Would love to understand your challenges with the cloud and how you've been able to address them as well. Thank you.